Hello there. This is the unretired engineer coming to you to talk about a slightly different topic this week, the orbital AI servers. I I've been following this for a year. Think it's fairly obvious. It's interesting to me as I write science fiction, sometimes fairly near future science fiction, and actually what I call the sun synchronous halo is turns up in one of the novels that I am working on right now. So I kind of looked at this early on. I had some real reservations because it appeared to me that people were really missing a couple of things. But I've really come to the conclusion that people have thought through this, that real engineers have dealt with this, and they do understand what they're doing, which I really never doubted. I just wondered what was going on. So, one of the early ones people talk about is, oh, it's space, you're going to have all these special chips and whatnot. Well, I've known that that's not true for a long time. A long time ago, a couple of fairly early CubeSats sent up iPhones and Android phones and operated them in orbit for some time with no problem. Essentially, radiation is a problem in deep space once you are beyond the Earth's magnetic protective field. But in near Earth orbit, that's not. That is, you're still protected, and so the problems with radiation are pretty minimal. And modern technology has reached the point where the hardware is pretty impervious to it, not perfectly by any means, and you certainly wouldn't send an iPhone to Jupiter. It would be fried within seconds. But in near Earth orbit, a modern GPU is going to be perfectly fine. In fact, they sent an H100 into orbit in 2025 and did some LLM training in space, and it worked perfectly fine. And they had a great. So Starcloud, which often shows some rather exotically impractical um, AI server concepts, have 170 million in Series A and at a 1.1 billion valuation. And I don't see that as being totally out of the realm. Elon Musk has talked about it. And a lot of what he talks about makes even more sense. Essentially, what he is talking about, which is a scaled up um, one of his communication sats kind of technology scaled up makes a lot of sense, and I think that's the way it's actually going to go. The FCC filing, cloud. Elon has a lot of satellites. Even Starcloud has 88,000 satellites at 20 gigawatts of compute. That's a lot of power, and the reality is you've got a lot of high energy solar power available to you pretty close to 24 hours a day, and it's very real. um, Now a lot of people assume that this is all going to work because space is cold. Well, the reality is space isn't cold. Space is a thermos, and as you well know, a thermos will keep anything hot or cold. It doesn't care. It just stops it from changing. And the reality is that's the problem in space, is that heat energy moves very slowly and only in one way. It is radiation is the only way to get rid of heat, and radiation is the least efficient way of getting rid of heat. So that was the thing that really bugged me in the early days. And, I've kind of come to say, okay, yeah, there are engineering solutions, but it's not a trivial thing. So, the reality is why space servers? Well, the reality is power. It's not really almost anything else. It's power plus it is resistance. In that there has been a AI, and a lot of this in general has created through some very stupid posturing or very Machiavellian posturing on certain people's part has really made AI a kind of anathema to certain people. The other thing is, it is another pivot, another access point for other actors. So, essentially, if as it is becoming a national requirement to have AI because it essentially is an accelerant for human intelligence. And I'm sorry, but war is all about human intelligence. It's also about blood and steel, but human intelligence is key to it. If you don't have it, you're going to die. And the reality is, AI is very intrinsically important for the military world moving forward. And essentially, a lot of actors have come in against it, not because they're against the United States, but because they're for something else, human dignity or human work or whatever. And they fooled themselves into thinking that being against AI is the thing. And then they've also said, oh, it's stealing our energy, and oh, it's stealing our water, and it's going to be loud, most of which is just bullshit. Reality is, all of these things are mitigated. Most of the centers design out those issues because it's in their best interest, and a lot of them will eventually become sources of power, sources of maybe even clean water and other things. And but the reality is, the perception is a reality, and the problem is that a GPU sitting on the ground not doing anything is a depreciating asset. And the reality is if you could put more GPUs into more data centers, you would make more money today, right? A lot of people say, oh, the AI, they're not making any money. They're not going to make, no, they're making money. They're making a lot of money. And the reality is they'd make more money if they had more compute. So building today is really necessary. And the resistance to building more centers everywhere in the world, except in certain places where we really don't want them to be built, is a problem. So putting them into orbit in a place where it's not regulated in the same way, it's regulated in much more of a technocratic way, um, a business way in orbit, is really a kind of practical. And you're getting, great insolation, lots of sun, um, and you are, so that's really good. But orbit is an expensive solution, right? No, but the thing is that it's an open frontier, and it's one where you can see if you can get your launch cost down, which is one of the biggest things that's going on right now outside of AI space, is the drive to get to orbit at lower and lower and lower cost. You can see that is going to happen. It is a matter of engineering and finance. It is not a matter of science or invention. It is just a matter of investment. It's going to happen, and if it's going to happen, then that means that your AI servers in space make more and more and more sense going forward. So, as I said, going back, so I was kind of a little bit questioning at first because space is not cold. Space is neutral. It is, and it is really negative for getting rid of heat. Um, if you and so there are a couple of things. Space, if you are looking up and you look into a black section of space, that means that is as cold as you can get. But your only way of getting to it is radiation, right? And essentially, if you're at 55 degrees C, then you can dissipate 600 watts per meter squared on two faces. 300 if it only one face is really your effective area. It's 300 watts per meter squared. That's 3 old-fashioned lights on a meter on a side. So 3 by 3 by 3, a bit more than that. But anyway, so um, that is, that means, and when you're talking about megawatts of heat, that's a lot, right? So you're talking about 1,200 meters squared for a megawatt. And radiators. I mean, you look at the one in your car. It has coolant in it, which is carrying the heat from the engine into the radiator. And oh, by the way, it's operating at a lot more than 55 degrees C. And so it's heavy, right? So large radiators are heavy radiators. There are things you can do, like using a heat pump. So you say, okay, it's 55 degrees C right here at the chip. Great. I boost that up to 175 degrees C, which, by the way, is pretty hot for the output for a heat pump. And I've got 3.5 times the amount of energy that I can set. So that 3.5 times less area that I need. So, but it doesn't come for free, because now you have the energy going into those pumps, and you have the weight of the pumps and the compressors and all the rest of that. So there's a big trade-off there, and it comes out that it does make sense to use heat pumps, but it's not like you're not getting 3.5 times as the advantage. It's maybe 2 times the advantage or less. And you also now have mechanical components which will wear out. Now, there's a lot of work going on in solid state cooling, which could really help a lot of that, but there's still moving fluids and all the rest of it. And the reality is that most really good thermal materials tend to be relatively heavy. Aluminum isn't. Aluminum's a good material for it, but usually your problem with aluminum is you need to get the heat to the aluminum, and that usually ends up being a heavier material than aluminum. But with all of that, so I'll go back. I haven't got direct experience. I have experience with cooling of machines and whatnot. So going back to my discussion on the onboard vehicle power and the transmission integral generator, there were a bunch of decisions we had to make about cooling, right? And the overall design of the machine. One of the things is it's a very peculiar machine in that it's an outrunner. It's like the machines that you see on little drones these days, where the rotor is actually on the outside, the stator's on the inside. That means that there's a lot of those machines today. It used to not be true. That used to be a very rare type of machine. Was when I was doing TIG, we had to fight. But I mean, it made a lot of sense, because your magnetics, which generate the torque or your power, are at the perimeter, at the largest diameter, where the radius and the speed are all at their maximum, which is giving you the maximum amount of magnetic advantage, right? And then on the inside, you have your stator, or the electrical windings, and then the cooling structure. Now, everybody at first said, well, but you're putting your cooling structure right against the carcass of the transmission, which is hot. I mean, you've got hot oil in there, and it's hot. And we all recognize that, but the reality is that we isolated the cooling loop from that to as degree we could, and then ran the coolant to the stator cooling. And we ended up with a system which was much easier to integrate into the transmission bell housing than any of the other approaches. So, and we didn't have that big a disadvantage thermally. So we were able to take advantage of the infrastructure in the best possible way and mitigate the disadvantages. And that's always the story when you're talking about thermals. You design your system around your limitations and your advantages to maximize and minimize in the best possible way to solve the problem. This is why engineering is a non-trivial exercise, right? Is because you've got multiple trades you're making, and you need to be very clear about what those trades are, so that you are not sub-optimizing something without realizing it. But at the end of the day, I see that radiator area and mass is going to be one of the bigger areas. I would say that it's going to lead to a renaissance in cooling, and working on solid state coolant cooling systems and moving moving the hot, moving it from the hotter to the cooler, right? Whether that's in a fluid or some gas or whatever, there's going to be a lot of innovation in that area. It's pretty exciting. So another driver for technology. So there are multiple companies doing stuff in orbit already, basically proof of concept. They're not at any scale that's making any difference to the world at large, but essentially Google and Starcloud and SpaceX are all running GPUs in orbit. They're all running software in orbit. They're all proving the basics, right? And all of them are also working on the basics of the technology of the cooling and the compute infrastructure and the operating in orbit and in the sun synchronous, all of which is highly important before you start launching specialty modules. So a little bit of a side note here in my notes. It's very interesting that certain AIs are very political, right? They're very biased. So even though I have multiple times talked about the targets and all the rest of that and where it's going, it keeps on coming back to the fact, well, you know, it's $1,000 a kilogram or more today. It's targeting $500 a kilogram in very short order, and $100 a kilogram is a stretch goal. And I mean, the reality is, I think I talked about this just a few minutes ago. The reality is, it's finance and physics, right? It is not, there's no magic here in getting it down. It is basically, you have to have a reliable launch vehicle that is relatively inexpensive to build and relatively inexpensive to fuel. And that is, again, reliable and can get to orbit and back, and you're not throwing everything, almost everything away every launch. That is going to happen. A lot of people are working on it. Elon Musk proved everybody idiots, right? Quite a few years ago, and everybody's been racing to catch up ever since. And they realized that there is an economy to be built in orbit, right? And everybody wants to get to it. And I think that's going to come. So, and then one of the interesting then knock-on things is the difference between a truck and an application, right? So when you are talking about Falcon or Starship, right? If you talk about it as a truck, then that dollars per kilogram is very important. But you also is very limiting, right? Because that's all you're going to get if you're launching somebody else's something into orbit. That's all you get, right? So it's a limit to what you make, and then you come back and you do it again, and you're a trucker, right? That's not necessarily the best business to be in. It's not a bad business because it's a critical business. It ain't going to go away, but it's also one where you're competing and you're always going to be driven down to kind of the lowest mean price. Whereas if you think of it that a single launch could be worth $30 million a year, right? Or $100 million a year. And if you're launching your own product, then suddenly launch cost becomes a very different thing in your calculation, right? So it is one of the reasons why SpaceX went the way they did, right? Because essentially launching their own product that once it's in space is generating cash for them, it means that they are not very sensitive to the price. They're reasonably insensitive to the price of space launch beyond a certain point. As long as they get down to a certain level, every increment of reduction is a huge advantage to them. And if something were to drive up the cost of, the RP fuel for a Falcon, it's not that big a deal, right? And so, but if you're a truck, it's a different thing. So I think that's one of the things that you have to look at when you're talking about all of this is what is the economy and what is the space economy? What is the orbital economy? Because it is beginning to be a very different thing than what it was when we were throwing every damn booster away every time, and most of the launch mass was government satellites. So, one of the things I ask is okay, so, okay, once you send that infrastructure up, right, then right now, well, they're talking about, oh, well, we'll be up there 5 years. In 5 years, the GPUs in those things will be no longer even close to the peak. So, and they'll probably, several of them will fail. We'll just deorbit and burn it all up in the atmosphere. I'm a little bit against burning everything up in the atmosphere. I understand it's only a few tons, and there's a lot of mass being burned up in the atmosphere with, asteroidal material coming in all the time. Still against it as on just general principles. But the other thing that I'm against is waste. And the reality is that solar structure, thermal structure, physical structure, infrastructure, and propulsion modules, they can operate for 20 years, maybe longer. I mean, we have stuff up in space which has been there for decades, and it has a tendency to have a very controlled degradation over time, if any, sometimes. And so, okay, so that GPU is no longer even close to the bleeding edge, but it's still generating tokens, so why not leave it up there? But after a while, it's like, oh, well, but that infrastructure has value, and maybe it's a lot more value if I put a new GPU in it. You design it just like you design a server rack. You basically pull the GPU out, plug in another one, and you're off to the races. You're back. And okay, that the one that you just pulled out, maybe it's been up in space, maybe it's damaged, but maybe it's just perfectly fine. It's just out of date. Maybe you bring it down. Hell, I would probably pay extra for having a GPU in my computer that has been in space, just for the cache. It's kind of cool. And what I'm saying there is eventually your economy is going to evolve in orbit. You're going to basically say you can put the satellites a couple of kilometers apart, right? They don't move. They're already there in orbit. It's then easy for a little tug to easily get from one to the next to basically change the servers out, do any maintenance or whatever, haul the used module back to a Starship, which is going to land it, and you take that back and it's scrap or whatever. I mean, as I said, maybe you can reuse it. And you can stack the orbits on top of each other by 10 miles, right? It doesn't take a lot of space, a lot of distance between orbital tracks to keep you safe, because it's all physics. Everybody knows where everybody else is going to be for the next 1,000 years. So, I mean, it basically rapidly comes to a point where you can start evolving an orbital economy, which is very, very, very different from what it is today. And I don't think anybody really knows what that is going to look like. But I think it's a fascinating set of thought experiments for an engineer, systems engineer, and sci-fi writer to think about. So again, that's kind of my view on AI servers in space, and hopefully I've given you something to think about. So if you like it, hit the like, hit the subscribe, and I'll be back to talk about similar things in the not too distant future. Cheers.